So hello everyone. Today our group are going to present about feedback control and integration using STM board. So let us begin. So the board we're currently using is the STM32, which is like the most important part on this lecture. We have no much time left, so we gotta go fast. Like just let you guys know we use this thing in our project. Yeah. Now here's the important thing. The flowchart of how this robot works is very simple. You just set up the ADC and timer interrupt, and also don't forget to set up your sensor minimum and maximum for its normalization. Then here comes the loop. If it get the minimum and maximum value, it would just repeat over and over. Otherwise, the loop will end and enter another loop where it set up the linear velocity. And for the another flowchart, I call it the period elapsed callback. You simply just manually input the ADC value and let the sensor normalizing positioning calculate, just let it do its work. Also, this part is clearly more complex than you could see. So let's go to the next slide where things should be more simple. So here, the main code is not that hard. Like it's clear, straightforward. Like I say, you just set up the values and let the program do its work. Like yeah, that is that. But here the timer interrupt, which has like more depth and information, and we have to talk more about that. So I'm done with my part.
So for the calculate error, we have the formula by we will use position to minus the set point, and we will define the error integral equal like 0 dt, and we have the formula for error derivative like in the slide, and after we move on the next slide. Yeah, we have inverse kinematics, output right equal the linear plus output, and over 2, and for output left we use the linear minus output and over 2. The next one is a code, and this one is pinout view. We set up the GPIO output, the PWM generator, timer interrupt, ADC1, GPIO, and we have the same thing in the slide. Next one. So this one is a variable declaration, and we'll declare sensor max, sensor min, KP, KI, KD in PIC controller. We have the arrow and LN for and RM for left and right motor, and we also define the speed equal 10.
And in this part, the normalization sensor. So we need to calculate and calibrate the sensor before using the robot, and this explain how the means and the max of the light that detected from the sensor, and then calculate it into the equation. Secondly, the positioning sensor. This part will tell that the sensor is in the middle part or not. Is it at the left or at the right? So yeah, it will calculate and tell the error and the position of it. The next tool is a calculator. As I say, use the position that got from the previous one. Then the PID calculator. With this equation, the Euler integral, Euler derivative at the output, it will calculate and send the information to the inverse kinematic. So at the inverse kinematic, it will control the output of the motor of left and right. Okay, and that's it. It's all of it. Thank you.